Now we're on our third and final video for the fundamentals. Then, once we have these fundamental concepts and principles, we'll be able to start figuring out how to actually calculate some of those probabilities that I just gave you in the earlier videos. In this one, we're going to be learning the and or rules. These are actually really important. They're ways of combining probabilities. We're going to use the same example that we've been using, right? Our quiz with 15 multiple choice questions. Each question has 5 options, right? So probability of success, 20%, failure, 80% per event. Now, we will start with a different kind of question. What is the probability of getting either 4 or 5 questions right? Maybe you're interested in getting one or the other. You can clearly see the or, right? We have the or rule here. So the way we would write this out in probability notation is something like this, right? Probability of 5 or 4 or 5. Right? So again, what's in here is the outcome or outcomes at this point, because we have now more than one that we're interested in. Right. Now, for the or rule is fairly straightforward for this example. We have the probability of 4 or 5 would be the probability of 4 plus the probability of getting 5. It's the addition rule. And here I've given it to you a nice bold orange letters. Or means addition. And remember from our previous video, here's our sample space of all possibilities and all of the probabilities. So then, actually calculating this probability becomes fairly straightforward. You can see probability of getting 4 right, 18.8%, 5 right, 10.3% adds together. So the probability of getting either one is about 29.1%. So you can actually see the utility of combining outcomes. You can see, well, 30%, it's almost 30%. Well, that's, a third. It's fairly likely that you'll get one of those two, 1 out of 3 chance. Now, there are other ways of writing these kind of questions, which I'll show you. But before I do, I want to put a little note here. And I guess the easiest way of saying this will get more complicated. And it won't get more complicated until a little later in this unit of probability. But I do want to just seed some vocabulary terms that you can look out for. Joint events, which is also known as non-mutually exclusive events. Now, I'm not going to go into what these mean at the moment. I just want to throw them out here now so that you can look for them and know that when this happens, this relationship is a little bit more complicated. And so at the moment, we'll keep it at a simple level and just look for these terms in the future. So, next question. What's the probability of getting at most 4 questions correct? Now, this at most term is very important. What does that mean in terms of outcomes? What outcomes are you interested in? Because, with this whole and or section, we're dealing with multiple outcomes. So if it's at most 4, then would 3 be included or excluded? Well, 3 would be included, because is 3, under 4? Yeah. So at most is the upper bound. So 5 is above the at most 4. So you wouldn't include 5 or any of these. So really you're dealing with 5 different outcomes, because we have 0 as well. And if you think about it, you can say, well, what we're doing is adding up this area of the graph. Not the whole thing, but just that area. And so to do that, we would have probability at most 4 would equal probability of 0, 1, 2, 3, and 4. You can think of this if you want to use the and or vocabulary. To answer this question, this is the probability of 0, or 1, or 2, or 3, or 4. It's any of those. So it's addition rule, and you'd add them all together. And it turns out to be something like this. So the probability of getting at most 4 right is about 84%. That now gives you some real feeling for should you guess on this quiz, because 84% chance of getting at most 4, well, maybe you should study and not guess on this quiz. It gives you some real information to work with. Now, another way of asking the question, what's the probability of getting at least 4 questions correct? All right, so it's no longer at most. What does at least mean? Well, it means that this is now the lower bound, the minimum. So it's going to include this and everything above, which if we look at this graphically is going to be this part of the graph. Oops. Something like that. So now, how do you calculate this one? And here we have all the individual outcomes, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you were to add them all together, about 35% of getting at least a 4. Right? So odds are you'll get under a 4. Now we've done the or, so all that leaves is the and. Now this is a little bit different, this situation. Because could we write the probability of 4 and 5 as an example? Actually, no. This really doesn't work because if you took the quiz, could you get a 4 and at the same time get a 5, right? They don't both coincide. But that's assuming just one quiz. All right? And one quiz is really one trial. What happens if we rephrase the question a little bit? What is the probability for getting 4 correct, for you getting 4 correct, and your friend getting 5 correct? So now we're talking about something that is at least possible. So this would be written out 4 and 5. What's the probability of getting 4 and 5? This, instead of the addition rule, the and is the multiplication rule. And there it is in nice big bold letters. So to see this worked out, it looks something like this. We have the probability of getting 4 right, the probability of getting 5 right, multiplication rule. And notice that you get a small probability. This is about 2% of getting both 4 and 5, which is quite different than when we were talking about addition rule. Notice that with the or, the answer was always bigger than any one individual part. It was cumulative, you could think of it that way. But with the multiplication rule, you actually get something smaller than any of the individual parts, which, of course, is a result of multiplication, right? You're talking about, 18 or about 19% of 0.103, so that's going to be a smaller number, What does that mean in terms of probability? Well, when we start combining, an outcomes like getting 4 and getting 5, well, how many different combinations are there with this quiz? I mean, you could have gotten 4 and your friend could have gotten 6, and you could have gotten 7 and your friend could have gotten 0. There's a lot of possibilities. When we start talking about sample space, and especially with the and, all of a sudden your sample space gets really big because there's lots of different combinations of 2 outcomes. So any one particular combination is only going to have a fairly small probability because the sample space is so much bigger. At least you can think of it that way. So, and that's really, fortunately, it doesn't really get much more complicated. The OR, I told you, gets more complicated, for the joint events. Multiplication rule actually doesn't really get more complicated. It's really just multiplication rule, which is nice. Once we have these 2 rules, now we can actually start figuring out how to calculate probabilities for outcomes.